Hello everybody, I'm Nick and today I'm going to show you the best .NET mapper that you are probably not using, and that is Mapster. Now before I dive into the code, I want to preface this video by talking about how I feel about mapping, because time and time again, every time I do a mapping video, people are commenting on whether you need or you don't need a mapper. And I'm going to give you my take just so it's on record. So there are two sides in this story, and one side is saying that mapping should be handled manually, meaning you should write the mapping method that maps from one object to the other. And the other side is saying that mapping is a machine's job and it should be done dynamically. I personally stand more on the second group, but not always. My personal take is that if you can't be asked to do the mapping manually, then use a mapper, and that's fine. But be very, very careful with two important rules, which by the way also apply to the manual mapping. First, always unit test your mappings, including ensuring that your mapping is correctly configured, and make deploying code impossible without those tests passing, like bake it into your CI. And the other one is, do not mix any of your business logic in the mapper. Do not make any external calls. Do not try to be fancy and use any dependencies during the mapping process. Do not get any information for the object you're mapping into from a shady internal source through the mapping process, because this is abstracting information that should not be abstracted in the mapper. So by not using any of those things just mentioned, you kind of safeguard yourself around the pitfalls of mapping. The third thing that people mention is performance, but we're going to take a look in this video and see how this might not actually be the case. Now, what I have here is a couple of projects, and we are only going to focus on the first one. And that first one is the mapping experiments, at least for now. So what I have here is this mapping benchmarks class where I have three benchmarks. We are manually mapping an object. We're using express mapping or express mapper to map it. It's one of the NuGet packages you can use. And the other one is automapper, which we've already covered in this channel, and you can click on the top right corner of your screen right now to take a look at that if you want to. And for a bit of context, I'm going to show you what's in this class. We're creating an automapper iMapper class. Ignore this for now, we're going to get back to it in a second. And we are also initializing a statically initializable express mapper. And this is how we're doing our mapping. The express mapper profile is registered here, while the automapper is at the very bottom here. And we're mapping this object, the product object, with these properties to this product DTO object, which looks exactly the same. That doesn't mean that this will normally be the case. Usually you're mapping from a domain object to a data access layer like your database DTO, or to your API contract, and they might look different, have less properties, have more properties on different places. We're gonna go for the very simple approach where the objects match and you have them separated, because if you want to make a change on your domain object, you don't want that change to break your database. So you don't use the same, you use a mapper to bridge between the two and make non-breaking changes safer, or breaking changes for that matter. And this is the object I have. I'm generating the exact same object every single time because I want the test to be consistent. So I won't just GUID.new or randomize the text. I want it to be the mapper's performance that we're measuring, not any other thing. And with that out of the way, I'm going to run those benchmarks and see what numbers we have. Oh, and also let me show you the manual mapping, how it's done. I'm just getting the object we want to map, and then I'm creating a new version and I'm mapping to a new object like this. So with that out of the way, I'm going to run the benchmarks using benchmark.net, another package that we have covered in this channel. And if you want to check that out, click on the top right corner of your screen right now. But with all that out of the way, let's give this a second, because it does take some time to run those benchmarks. And in the end, we're going to have some reliable numbers. So let's just wait. So the results are back. And if I scroll up, I can see that the manual mapping is actually the fastest, surprise, surprise, with 100 nanoseconds. Second is automapper with double that time, but we didn't actually write any code to do the mapping, and it used the least memory, and it didn't have any Gen 1 garbage collections, while the manual mapping did. We're gonna see why that happened in a second. And then express mapper with the slowest. Now, automapper gets bad rep because before I think it's before 5.0, performance was really bad, but lately it has improved significantly. And even though the mapping looks basic, this is the type of mapping that you should be using a mapper in the first place for. If you have complicated mapping with insane rules and on before and on after, you probably should manually write your mappers and separate those heavy things outside the mapper because you're misusing your mapper. So these are the stats we have for the mapping right now. What I'm going to do is I'm going to introduce you to a NuGet package called Mapster. And Mapster has a few interesting things going for it. The first one I'm going to show you is how you can do mapping with Mapster, like straightforward mapping the same way we're doing it for the ones that we already have. So let's build on top of what we have. We're going to go to the benchmarks, and I'm going to add a new benchmark, and I'm going to name this Mapster adapt, and I'm going to show you why. And I'm going to name this Mapster adapt example or sample, and I'm going to create that method. And I will need to move that a bit up. So what we need to implement is using Mapster adapt from one object to the other. Now, the only thing I'm going to do is say return generate product, which is the product that we are going to map from, and then dot adapt, and then product DTO. And this adapt method doesn't need a profile to run. It will automatically detect the incoming and the target, the destination object, and will do the mapping dynamically. So I'm going to run this. And again, we're not using this thing that exists up here. Forget about this for now. I'll just have it so I don't spend much time writing code. All I have is an extension method that Mapster, which is a package you can find under the name Mapster here, version 7.0 is the one I'm using now, is providing. So back to the benchmarks, I'm going to run this. Let's wait for a second and let's see how Mapster performs out of the box. So that is now done. Let's go up again and see that Mapster now is not only the one that uses the least memory out of all of them, but it's also the fastest out of all of them, even from the mapping, the manual mapping. So that is weird, and we'll see why the manual mapping is not as fast as we'd like it to be. But it's very interesting that the adapt method, being completely dynamic, is able to outperform what we wrote. So that's fine, but this is not normally how you would map using Mapster, because this is a very, not rough method, but it doesn't really accept any configuration at this state. So what we want to do is do the same thing, but provide some configuration. And for that, I've created this method returning some config. And what I'm going to do, just because I don't want to reinitialize this object over and over again, I'm going to say private static read-only type adapter config, which is the configuration for the adapters for Mapster. And I'm going to name this, type adapter config. That's pretty easy. And then I'm going to statically use that here. But I'm not going to use that yet. What I'm going to use is I'm going to change this method to be named adapt without config. And then also add a new one with config. And this will use now in here as a property the config. Let me copy that because I forgot the name. Here you go. And what the config has internally is basically the same thing that you would have in AutoMapper using the new map or add map. You can have tons of rules and compiler settings, and you can say apply, fork, scan. There are many features that I cannot talk about in a single video. This is more about the other features that are coming down the way that Mapster supports. But the normal thing you would do is you would do new config like we do here to create a mapper, and then you would have the Fluent API here to do other things, again with before mapping, after mapping, ignore, if, map with, things that you would have or features that you would have in AutoMapper or other mapping platforms. There's nothing special about it in that sense. And I'm going to change my benchmarks to say Mapster adapt without config, and change that without config sample. And then I'm going to add the other one with config. But even then, these are not the only ways you can use Mapster with. In fact, it's not really how you will use it. How you will use it in a realistic scenario is more like this. You would, and this, I'm going to change it to adapt to type sample. What you would have is you would have an iMapper, same way that you have in AutoMapper, so you can mock your tests and mock your mapper and do other things with it. And then you would use this mapper with the provided config to use it in your API. And I do have a sample here which shows you how you can do this. If you check the code in the description, you're able to check that out. I'm not going to be talking about it, but there are packages that make it simpler. And then I'm going to use the Mapster mapper that I created. I'm going to say Mapster mapper.from, so which object I am mapping from, and I'm going to say generate product, so I'm mapping from that product, and then adapt to type product DTO. And now the config is baked into the Mapster mapper itself. And since this is basically a Fluent API, you will be able to do other things with it in both mapping and config, and also the way you're adapting. You can fork, which is another interesting thing, or create a projection expression. There are more advanced features that I won't be covering in this video, but I highly encourage you and recommend you to take a look at it. So now we have this new method. I'm going to add it in the benchmarks, which I am failing to click. Okay, here we go. Adapt to type, and I'm going to name this adapt to type. Here we go. And now we have all the Mapster, like straightforward mapping benchmarks in place, and I'm going to run this. Now this will take for me a few minutes, for you just a cut, but let's give it a second for you as this is running. So the benchmarks finished running, and I can scroll up, and now I can show you that the adapt with config is now slower than the manual mapping. That's because it actually uses pre-defined rules, and it's not using the very straightforward, dynamic and optimized way that the no config version is using. And then the adapt to type, which is using the quote-unquote proper way to do it with a from and an adapt to type method, is somewhere in the middle between AutoMapper and the manual mapping. Now you might say, okay Nick, that's just another mapper. What's the point? 50 nanoseconds is nothing. I might just as well use AutoMapper, which I already use and I like. That's a very fair point. But here we're gonna dive into some advanced things. Mapster supports code generation for mappers, which means that it will write the code for the mapper for us in a manual mapping way. With code generation, we're gonna just instruct what we wanna map towards, and then Mapster will technically write the code for us using code generation, and we'll be able to use that in our application, providing very, very fast performance. Technically, it's as good as the manual mapping performance. So the first thing we need to do for this to actually work is go to the terminal of your application, and I am going to have to cd into the mapping experiments, and then I'm going to do .net new tool manifest. So this create the manifest file for me, and then I'm going to do .net tool install mapster.tool. And as you can see, this has now been installed. And this is a CLI utility for .NET, which will be used by the automatic code generator that will write the C# file for us. The other thing that I need to do now that I did that is copy a few things that, by the way, exist on Mapster's website, and I will have a link in the description down below for you to use. And we're going to edit the csproj file, and at the bottom I'm going to paste this. You don't really need to know what it is, but it's basically including the automatically generated CS files that Mapster will create, and also gives it a few tasks to do as part of build. So let's close that. And we don't really need to include any other package. All we need to have is Mapster here in NuGet. Now, with that out of the way, the only thing we need to do on our products to create the mapper is to go at the top of the class and say adapt to, and then I'm going to use the following format just so we can have consistency. Name, and name here defines the class name that we are in. So product code gen DTO, and this, if I build, it will actually create the DTO, but that's not just what I want. It could be, you could just create the thing you're mapping to using Mapster, but in my scenario, I'm going to also say generate mapper, and I need to do that outside of this. So generate mapper. And now when I build, let me show you what happens. So if I scroll here and show you, a few things have happened. The Mapster tool was installed and restored, and then it was run for both model, extension, and mapper, which means that the models folder now exists. What is the models folder? The models folder is where Mapster will automatically put the things that it generated, the models and the mappers. So first, let's take a look at our DTO. Oh, look, we didn't write anything, but we have our OK. I missed one. The product variant should also have the exact same rules. So let's go back to the product, copy that, and then go to the product variant, my bad, and do basically the same thing. Add the exact same mapper on top of it and push that forward. And now let's do this again. And now we have the proper generated code option here because we do have the adapt to attribute, and we have a mapper for it, a mapper that we did not write. It was written automatically by Mapster's utility. And same thing for the variant mapper, and same thing for this. So let's take a look. Let's make a benchmark for that, and let me show you how you can map using the CodeGen version of Mapster. So now let's just take a look at how we can benchmark this and how we would do a mapping like this. So we're going back to the benchmarks, and I'm going to add a new benchmark, which is Mapster code gen, and then Mapster code gen sample. I'm going to create that method, and I'm going to move it up. Here we go. And what I want to do is I want to say return, and then the object, which is generate product dot, and then as you can see in the bottom, we have a few new exceptions. One of them is adapt to CodeGen DTO. This extension, I think I said exceptions before, sorry, I meant extensions, has been automatically generated for us. And I'm going to return that. Of course, we cannot return the same product DTO because now we're mapping to a new DTO. So product code gen DTO will be used here. And we don't need any settings or anything because all those settings are baked into the code that has been already generated for us. So back to the benchmarks, I'm going to change that to product code gen DTO. And again, we have a mapper without writing, well, actually with writing just a single code, which is the attribute. How amazing is that? I'm going to run those benchmarks now, and let's see what we get at the end. So benchmarks has finished running. So let's take a look at what we have. Oh, interesting. So Mapster's code gen is 50 milliseconds Mapster than my manual mapping. That is very interesting. So I'm sure that I didn't write the best code I could in my manual mapping, and we can optimize that. And I'm going to show you very quickly how we can optimize that. But the best performance you can get out of the box, and then customizing with a few attributes if you want to, and get that, that's amazing. This is truly amazing. A very interesting proposition if you just want to do very simple mapping, which is what you should be doing really anyway. But let's see how we can optimize our own mapper before I wrap up this video. So what I have in my manual mapping sample is I did the dirty thing of using link, which is not as performant. I mean, again, this whole thing is on the scope of nanoseconds, which is 1/1,000,000th of a millisecond. So this is probably not your application's bottleneck. And if you're using AutoMapper, you're gonna be fine. But if you want to support a project that is doing something really interesting and could be something way more than it is right now, take a look at that, check it out. I highly recommend it from what I've seen until now. So let's optimize this a little bit. What we have here is I'm gonna create a DTO here, and I'm not gonna attach the options yet. So I'm going to leave that empty. And then I'm going to say var options equals new list of product variant DTO. And then I'm going to say for what do we have here? Product dot options dot length or count. That's fine. And I'm going to change that to a var. And then I'm going to say options dot add. Wait a second, why don't I have a for each loop? Oh, because for is marginally more performant, I think. I could be wrong on that, but I think that's the case. At least it used to be. So let's use that if I could type. So product dot options, do a read and get the ID. And then the same thing for color and size. So size. And then also color. And with that small optimization, I'm going to say DTO dot options equals options, and I'm going to return the DTO. So that should perform better. I'm going to run those benchmarks again, and let's see what we get. So here we go. All the tests have completed, all the benchmarks, and as we can see, my code is still not as performant as Mapster's automatically generated code. So I'm sure if I dive more into what I wrote, I can optimize it, but at that point, I'm just wasting my time. I might as well just use Mapster. And again, this is not a video showing you all the features that Mapster supports. This is just familiarizing yourself with Mapster and giving you a motive to go and check it out and learn more about it. If you want a dedicated video on its feature set and the mapping capabilities, I can do that in the future. But for now, we're gonna leave it here. That's all I had for you for this video. Thank you very much for watching. Special thanks to my Patreons for making these videos possible. If you want to support me as well, you're gonna find a link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well. And I'll see you in the next video. Keep coding.